Greetings, Doctor. We are here to talk to you about the research of light-emitting diodes. Our presentation is in four parts. Firstly, I will going to introduce the structure of an LED, which is a semiconductor light source that emits light when current flows through it. Now we can see the part of a conventional LED on my left-hand side. Here we can see there is an apostrophe lens. It is the casting of an LED. Then there is a LED frame connected to the cathode terminal, also known as anvil, that holds the semiconductor material. The refractive capacity which is connected to the anvil actually holds the semiconductor materials. Now we zoom in to see the layer structure of the LED. It consists of three layers: P-type semiconductor, N-type semiconductor, and depletion layer. N region is placed at the bottom, so it is connected to the cathode terminal, while the P region is at the top. A wire is connects it to post LED frame, which is connected to the anode terminal. Lastly, we can see a flat spot on the exposed P casing that prevents twisting from damaging the LEDs.
Now, we are going to part 2. What I'm going to talk about in part 2 is the basic operation of LED. As we said at the beginning, LED is an optical semiconductor device that converts electrical energy to light energy. So, LED are made from compound light, gallium arsenide, and other semiconductors that emit light. Silicon is most widely used in normal diode. However, it does not release energy in the form of light. So, normally they are not used in LED. What we need to know is LED only emit light when it is forward biased. When the current flows from the anode to the cathode, the LED will be on. If we apply current in opposite direction, the LED will not light out. Like other diodes, LED will allow current flow in one direction. Normally, these diodes are formed by a p-n junction. This is a semiconductor p-n junction. When LED is forward biased, holes are pushed by positive terminal toward negative side, and electrons are pushed by a negative terminal toward positive side. During the process of flow of hole and free electron, there will be a recombination of modem. This means free electron will recombine with empty holes. During the recombination, free electron in the conduction band will jump to the hole in valence band. During the jump of electron emit light in the form of photon. From the energy diagram, we can see the forward biasing, and they narrow the depression region and allow the free electron to cross the junction, then energy release. LED can be many color, and the semiconductor material used in it determine the color of LED. This is because photon has different wavelength based on their energy. So, to achieve different color, we have to figure out how much energy an electron passing from one material to another need to lose in order for it to emit the photon of the correct wavelength for the desired color. Before using LED, there are a few characteristics of LED that we know it. Let us start from the most important characteristic of the LED, which is the light generated by the LED is directional. This means they emit light in a specific direction. No light is wasted. The second characteristic of the LED is they can generate different light color. The color of the LED determined by the wavelength of the photon. The color of LED can be red, green, blue, and so on. More important thing is LED has low power consumption. They consume less power and they can use even if the DC power supply is low. In addition, LED has a long lifespan compared to the traditional lighting solution. The lifespan of an average LED light is 50,000 hours. Not only that, LED is cheaper than other traditional lighting solutions. Besides that, LED is small and fluctuating. This is also an advantage of the LED. However, there are also some disadvantages of the LED. For example, when overcurrent in the circuit, the LED may get damaged. This is because the current already beyond a certain limit.
In the final part, LED has a major role in development in the technology from past to present. It has come a long way since the early days of lighting up digital clock faces. Like in the 20s, LED TVs looks over the high deflection market and represent a huge step over Old standard definition CRT televisions, LCD displays were even a major step above HD reproduction, but LED technology changes the market. LCD TVs still use cold cathode fluorescent tube to project white lights onto the pixel, which is add weight and thickness to the TV set. In the opposite, LEDs solve both problems. There are several types of LED backlit sets are on the market and not all are created equal. Most sets use the white LED edge lighting to shine light across the display. Some of the newest LED displays are made with organic light emitting diode known as OLEDs. The material used to create these semiconductors are flexible, allowing researchers to develop bendable lights and displays. Some manufacturers have already started producing smartphones and other devices that use OLED screens. As the technologies allows better and larger displays, people may start seeing them in places that would never have been able to find a screen before. Well, that is a total wrap of the light emitting diode. Thank you for watching and stay safe, everyone.